What is the biggest number you can think of? A billion? A trillion? Whatever you just thought of, I can always add one to make it bigger. Yeah. But here's a mind-bending question. Is there a difference between numbers that are truly infinite and numbers that are just ridiculously unimaginably huge? Today, we'll look into the fascinating world of theoretical and practical infinity. Before we get lost in the endless void of infinity, be sure to hit that subscribe button, though I promise we won't count that high today. Let's start with a simple thought experiment. Imagine you're playing Minecraft and decided to walk in one direction forever. Theoretically, you could keep going infinitely, right? Well, not exactly, even though now it's sad you should be able to. Welcome to something called the Farlands. At around 12.5 million blocks from the center of the world, the landscape becomes a glitchy mess of impossible terrain. This is a perfect example of practical infinity. The point where something designed to seem infinite hits its actual limits. But what about theoretical infinity? That is the real infinity, the concept that there's always something bigger, always something beyond. It's not just a really big number. It's the idea that numbers never end. Think about it this way. Practical infinity is like counting the grains of sand on the earth. It's an enormous number, but it's finite. Theoretical or the real infinity is like trying to count the points between 0 and one other number line. No matter how closely you zoom in, there are always more points to count. Let's talk about some mind-blowing, practically infinite numbers. First up, the Google. Fun fact, this was actually how the Google, the famous website, was supposed to be called. But the developers made a mistake in registering the domain. Google is a 1 followed by 100 zeros. Sounds big, right? Well, it's nothing compared to the Grimes number. Grimes number is so massive that if you try to write it down, there wouldn't be enough atoms in the observable universe to hold all the digits. Yet, mathematically speaking, it's still finite. Practically infinite, but not theoretically infinite. In computing, we run into practical infinity all the time. Your computer cannot come to infinity, but it actually can count to 2 over the 64 minus 1, which is about 18 quintillion. That is the maximum integer many computers can handle. Try to go higher and you'll get what programmers call an integer overflow. But here's where it gets really interesting. In mathematics, there are different sizes of infinity. The infinity of counting numbers is smaller than the infinity of decimal numbers. Don't believe me? Let's prove it. This is called Cantor's diagonal argument, and it shows that some infinities are bigger than others. It's like having an infinite hotel that's fully booked, but still being able to add more guests. Math is just weird like that. So why does all this matter? Understanding the difference between theoretical and practical infinity helps us grasp the limits of our real world while appreciating the boundless nature of mathematical concepts. It reminds us that even when something seems infinite, we might just be looking at a really, really big finite number. Whether you're dealing with computer memory, scientific calculations, or philosophical questions about the nature of the universe, knowing where practical infinity ends and theoretical infinity begins can help you understand the world better, and maybe even win some nerdy arguments. So next time someone tells you something is infinite, ask yourself, is it truly endless or just practically infinite? And remember, even though you cannot count to infinity, you can always count to hitting the like button and subscribing for even more interesting math concepts. So again, thank you for watching and peace out.